welcome to another episode in the PWA series. So in the last episode, we looked at different caching strategies, but that was just a theory part. In this episode, we'll actually try to apply whatever we discussed on the caching strategies. So essentially, we look at different resources that we're using in our e-commerce app here, and then try to apply the appropriate caching strategy. But before that, let me quickly go over some code changes since the last episode, because we'll be navigating an updated code base, and it's important to understand the changes in order to follow and go on in the series. So let's jump into the code changes, and then we can get to the meat of this video. Okay, we're on the Chrome browser, and this is our e-commerce app. So the first thing you'll probably notice is that we changed the styling of the save button. The more significant change is how we are storing the data underneath. Previously, we stored it in memory within a map data structure, but the code base has been updated to actually store the data in the local storage, which is actually in the browser. So you can actually see that here. So if you go to the local storage, see that we have the products, the shopping cart, and the favorites. So these are the different data collections like for the products that we're using in the app here. So now the code or the web page actually picks up the data from the local storage in here. And if we go click on each of the collections, we can see the data that is available that is rendered in different web pages. So this is the favorites. And if you go to the products, so see the shoes, the sunglasses, and then the retro camera. The reason we made this change from the in-memory to the local storage is because each time we add some data, say like some products to the shopping cart, just add it to products, and let's mark a product as a favorite too, an additional one. So this is the home page, and if we actually switch to a different page, like the favorites, right now we have that changes done on the other page retained in this new page here, like the items in the shopping cart and also the additional favorite that we marked. But with the previous version, this wasn't possible because we were initializing the data to some initial values and it was getting reset with every new page load. So the local storage was actually used to fix that issue, and also because we don't have a backend yet. So that is actually the significant change in the code base from the previous episodes. Let's go to the Visual Studio Code as well to look at the changes in different files. Okay, we ran the VS Code. The main change is in the app.js file, which is where we actually stored the data for different product collections. So previously it was map data structure. Right now it is just objects, because local storage just stores objects as key value pairs. So just like the product, the favorites is also now converted to an object here. And then we have the names of the collections, which are actually stored as the keys for different product collections. And then we have an API built on top of the local storage API using the set item and the get item and other methods. So this API actually is the way for the code in the web pages, like the favorites listing.js and the product listing.js for both the pages, to access the local storage and manage the data within the local storage. So since local storage only stores key value pairs, so the collection name becomes the key and the actual collection becomes the value right here. So with that API, we actually initialize the data in the app as well in app.js. So what we do is we get the current state of different collections right here with the get method, and we give the corresponding name of the collection as input. And after that, we actually initialize the local storage with the add collection to local storage method by considering the current state of the collection. So if it is empty, we set it up with the initial values, and if not, we set it up with the current collection state itself. So that way we preserve any changes from one page to another, preventing any data loss. So with that, appropriate changes have been made in product listing and favorites listing files too. So if we go here, the first change is at the top, the isFavorite method. We're using isItem in local storage collection, which leverages the local storage API that was created in app.js. So I would recommend taking some time to go over the code changes so that you're on board and up to date with the code base at this point. And also I've created a separate video covering the code changes with the local storage. So if you're interested, you can check out that video as well. The link should appear on the screen. Okay, with the discussion of code changes out of the way, Now let's get to the main part, which is applying different caching strategies that we discussed in the previous episode. Let's go to service worker. In the service worker, right now we have the static caching being done in the install event handler. Then we have the cache cleanup in the activate event handler. Finally, the fetch event handler, where we intercept any fetch requests from the two web pages and handle it in this cache with network fallback strategy. So I hope you can now relate this strategy with the cache with the network fallback strategy that we discussed in previous episode. Because we first check the caches, and if there is a response, you just serve it right away. And if not, we make the fetch request to the network and then cache the response for future requests and then return the response. So this is fine for the dynamic resources, but for at least the static resources, we could just serve it up from the cache directly using the cache only strategy. So we can have a conditional approach in the fetch event handler here based on the requested URL. And if the requested resource URL matches with any of the resources in the static cache, we could just serve it from the cache directly without having the need to go to the network. So the cache with fallback kind of handles that too because we access the cache, but the strategy is more precise because of the type of resource that we have, which is pre-cached resources in the static cache. So let's make the change here in the fetch request handler. But before we make the change in the fetch handler, let's store these static resources in a separate variable because we'll be using in multiple places now. So let static resource list equals, let's cut this part. Now let's use it in the install handler here. So this way we'll be able to use the static resource array in the fetch handler as well. So let's go here and now start with the change. So if in this condition, what we want to check is whether the URL in the event request here, if at all it is part of the static resource list. So to do that, what we do, we actually convert the array to a string. So we use the join method in the array API. So let me go to the browser. So here we have the join method in the array API. So the way we can use the join is to convert the array into a string by concatenating all the elements in the array. So in the example here, we have the elements, which have these three fire, air, and water elements. And then with the join, it just converts it into a string by just concatenating them with the comma separator. So that is the default separator there. So we'll just use that. So we'll do static resource list dot join. So once we have all the resources concatenated as a string, now we can do a comparison of that string with the URL that we have in the request. So we'll have to use another API for that, which is the URL API. So back to the browser. So we have a special API just for the URLs. So we can create an instance of it using the new URL instructor. And in that we have other properties from which we can extract just the path, excluding the domain. That's important because in the array of static resources, we only have the path from the root for resources on the local host. So if we go back to the VS Code, apart from links to other resources like the fonts and the material design light, the rest of the resources are local, like in our code base, and we don't have the local host with the HTTPS protocol. So it's important to have this format for the resource when we compare or look for a match within the array. So for that reason, what we'll do here is we'll look for a match using index.auth of the string API. So what index.auth method does is it takes an input string and searches for its first occurrence that it is being compared to. So in our case, the output of the join method, which is the concatenated string of URLs, will be looked up by index.auth method, and we'll be giving the URL in the request as an input. So let's do that. Since we looked at the URL API, we'll be creating a URL. It should be URL. Then we give the URL in the request as the input. And if a match is found, then index.auth returns some valid value. Otherwise, it returns -1 as the return value. So a hit means it should be greater than -1. So just for reference, let me quickly go back to the browser again. And here we have index.auth method as well. So as you can see here, it returns the index within the calling string and it returns -1. Value is not found. So here is an example. So we have the paragraph here, and the search term is dog, and the index.off, we're searching for the dog term in the paragraph. And what we get back is the full stack reference, or the index of the start of the search term. So that is what we're using in our code in Visual Studio Code. So I'll leave links to the resources in the description, so don't worry about that. So if we have a hit, okay, it should be outside the bracket. So if we have a hit, we use the cache only strategy, and if not, we use the cache with network fallback. So that way we can use different caching strategies based on the URL. So let's finish up this part here with the cache only. So again, event.respond with, we check the caches directly. So we can directly open the static cache, cache list.static cache. So better readability, let me put it down on a new line. And since it returns a promise, we get access to the cache reference in the then method. And once we have access to the cache, we just return whatever would be our response with the match. So we do the match, cache.match, and event.request.url. So this is more specific, targeted at a specific cache with the desired resource. Just for debugging purposes, let's console log a message saying from where the resource is being served, whether with the cache only or cache with network fallback. So let's console log it here. So service worker log, then serving with cache only. Let's add the resource here. Also here we need to get the path name because we want to have some match, just the path. So if we do dot, we have the host, the path name there. So we use path name for the precise match. So let's just console log a message here as well, cache with network fallback. Now let's go back to the Chrome browser, see if we're able to serve the request from the appropriate caching strategies. So let's go to the service workers section, go back to the home page. Let's clear up the storage as well. Now let's try loading the home page. Okay, the service worker is active, and if we go to the console log, we won't have anything printed out because service worker just took control over the page and we need to reload again for it to take effect. I see you have all the logs being printed there. It's only partially loaded. Let's reload again. Now the page is fully loaded. So let's check out the logs to see if our code has taken effect to conditionally load different resources with different caching strategies. So if you see there, we see that the material icons, material design light, then other local resources are being served with the cache only strategy. So it seems to be working with the static resources being served from the static cache. Then we see that the explicit font file is being loaded with cache with network fallback. And then the other resources as well, like the images for the products, which are not part of the static cache. So our logic seems to be working and we're able to conditionally load resources. So right now, because we don't have a backend yet, we won't be able to use other caching strategies like e-cache then network, which will be more appropriate for the products that we have here. Because the product collections are more prone to frequent changes, the cache then network would give us both the speed and also the latest version of the collections or the data. So once we add the backend, then we can update the fetch event handler in the service worker to incorporate that as well with the appropriate URL. For now, we'll just stick with these two caching strategies, cache only and cache with network fallback. I hope you were able to get an idea on how to use different caching strategies in your web app based on the type of resource. So let's just stop here because I think the video is getting a little lengthy and also keeps it more focused on just the implementation of caching strategies. So we'll look at the on-demand caching in the next video. So stay tuned. And as always, if you happen to like this video and the content, do consider giving it a like and subscribing to the channel. So thanks for watching and hope to see you in the next one.